Welcome back, grade 12 learners. In this video, we're going to look at finance. This is actually part one of a three-part finance videos, and part one is going to be the introduction to annuities. Finance, part one of three parts, and in this part here, introduction to annuities. Let's see what we want to achieve in this lesson. First of all, we're going to just do an overview of some of the essential finance concepts and skills which you would have done in grade 10 and grade 11. Then we're going to look at the concept of annuities, and then specifically we're going to look at the future value of an annuity, and then the present value of an annuity, and then we're going to do some applications, some direct applications of present and future values. And as usual in all my videos, we will end up with an exercise worksheet based on these concepts. Let's start with an overview of some essential finance concepts and skills. Let's start off with a comparison of simple and compound growth. Right? Let's say for example, we have 20,000 rand that is invested, and we invested at an interest rate of 20% per annum, and we're going to invest it over a period of, let's say, 5 years. Right? For simple interest, we know this is the formula for simple interest: A equal to P1 plus I times N, where A is your final amount, P is your initial amount, I is your interest rate, and N is the number of years. So let's see now. Let's say for over 5, so initially we start off with 20, then it grows to 24, then 28, and 32, and 36, and 40. I mean, that is now using that formula. If we just represented it graphically, we can see there, as you can see, that's the value after the first year, value after the second, third, and fourth year. And if we look at that, we see, join those points, we have a linear relationship. Right? So that growth, simple growth, is actually a linear relationship. Let's look at a compound growth. We substitute those values. We start off with our 20, same amount for the first year, but you see there the amount increases because it's compounded. And let's just get a visual picture of that. You can see the first year it was the same, and then it grows there. And that is not a linear relationship. This is referred to as exponential growth. So you see there's a big difference between simple growth and compound growth. Next, we're going to look at the effect of different compounding periods on compound growth. Right? Let's say that we have 10,000 rand and it's invested at 40% per annum. I know it's a bit high, just use that. So the different compounding periods could be annually, in once a year, semi-annually, that will be twice a year, quarterly, that will be 4 times, and monthly, that will be 12 times per year. So that will be the formula to use for annually. Semi-annually, there are 2.5 years, so we have divide by 2 and times in by 2. Quarterly, there are 4 quarters, so we divide 4 and then we times it by 4. Monthly, that will be divide by 12 and times by 12. Let's just look at it graphically. Let's have a graphical comparison. So if we plot that, that is the graph it will get there. As we can see here, for annually, that's the time value there after 5 years, and then semi-annually, that's the time value that we'll get there, and quarterly, the time value is more, and monthly, it's even more. So if the number of compounding periods per year increase, you can see the time value would also increase there. Next year, we're going to look at the nominal and effective interest rates, the 2 types. There are 3 questions we need to ask ourselves. What are nominal and effective interest rates? Why do we need them? And how do we go about converting from the one to the other? Let's start with an example. Let's say we have 15% per annum, which is compounded monthly. So the compounding period here is monthly. Now this interest rate is referred to as the nominal interest rate, right? It's not compounded annually but monthly, or could have been quarterly, or it could be semi-annually. Now we'd like to know what should the annual interest rate be, not the monthly one, but has the same effect as that 15% compounded monthly. That must have the same effect. And this interest rate, this annual interest rate, is referred to as the effective annual interest rate. Why do we need that? In annuities, let's look at an example. We're going to have regular monthly payments. And in this case here, the interest is compounded annually. Now in annuities, if the payments are monthly, the compounding should also be monthly. Or if the payments are quarterly, the compounding should also be quarterly, right? So we have to convert from the one to the other. How do we go about that? Let's take an example. We have 1,000 Rand, which is invested at 15% per annum compounded monthly. And we'd like to determine the annual interest rate having the same effect. What does that mean? We want to determine the effective annual interest rate. Okay, so let's just do that calculation. 1,000 Rand at 15% for a whole year, and that yields us 1,160.75 cents. Now to have the same effect, I want to know what should the annual interest rate be having the same effect. In other words, I should also obtain 1,160 Rand and 75 cents. Now these two are equal. So in other words, I can have the 1,000 with the 15% should be equal to the 1,000 with the effective interest rate. Now we notice there are thousands on both sides, so we can cancel out the thousands. And this leaves us here with a way in which we can show how we can convert from effective to annual. So if I just look at this here, you can see 1 plus the effective, and that stays a 1, so we don't have to write down the 1. So that gives me that part. And instead of 15%, I have my nominal interest rate. And for the 12, I put my compounding period. If this was quarterly, I would have a 4 there and a 4 there. If this is semi-annually, I'll have a 2 there and a 2 there. If this is daily, I'll have 365 and 365. So this is what we'll use to convert from nominal to effective, or from effective to nominal. Next, we're going to look at we previously now looked at growth. We're also going to look at decay. We're going to have a comparison between simple and compound decay. So let's say we have 40,000 Rand, and the depreciation or the decay is at 20% per annum, and we're going to look at over 5 years. A simple and compound. For simple, that's the formula 1 minus I times n, and for compound, we're going to look at that afterwards. So let's see now. If I take 40,000, so in other words, we start off with 40,000. I just don't have the thousands in there, and you can see depreciate by 8,000 and another 8,000 and another 8, until eventually after 5 years its value is 0. So when we have a simple decay, the end value there would be 0. If we take compound again, but before we do that, let's look at it graphically, and you can see that there again the simple decay gives me a linear relationship, and you see after 5, then after 5, in this case of the 20%, the value there would be 0. Now let's look at the compound decay. There's the formula for compound, 1 minus I to the n. And we start off with 40,000, and then after the first it's the same. And then it just decreases gradually. But it never, you see this one ends up with a 0, this one here will not end up with a 0. If we just look at it graphically, you can see the graphical representation there. You can see it's not linear. It actually gives me there's this one here. It has also an exponential function here, but it never reaches the 0. There's an asymptote here. And if you just join those points, we see that that's the compound decay. It will never attain 0. It doesn't matter how far we go there. Let us just summarize what we've done, growth and decay. Decay is also known as depreciation. So if we look at in growth, which is also known as inflation, for simple, that's the formula we use, and for compound, that one. In the case of compound, this is where we're going to have inflation, right? This is what we use if we talk about inflation. Then decay, we'll have the simple decay, is also known as using the straight line method. That's the formula we use. And then for compound decay, which is also known as the reducing balance method, and that's the formula we use. Please note that inflation here applies to the compound, not to the simple. Next, we're going to look at some of our calculating skills, and specifically how to calculate the interest rate and how to calculate the period. Let's take an example. Let's take a growth, P1 plus I, is compounding interest, and we want to determine the I value. How do we go about that? First of all, it is advisable in the problems, always do the substitution first. After substituting, then you can make I the subject. Now, if I want to make I the subject, this power n would become an nth root, right? So we always do the opposite. Addition becomes subtraction. A power becomes a root. So if I have that to the power 3, this will become cube root. That to the power 10, that will become 10th root. Let's just look at an example. Here, after doing the substitution, we have 3,000, and the growth was up to 5,000. And we want to determine the interest, the annual interest rate. So first of all, we have to get rid of that 3,000. So what do? We divide by 3,000. Instead of multiplying by 3,000, we divide by, and try not to, please do not use your calculator at this stage. Just keep it in 5,000 over 3,000. Then if I want to get to the I must first get rid of the 4. So instead of the power 4, I can get the 4th root of 5,000 over 3,000. Then we have to transpose the 1. Instead of adding 1, we subtract 1. And after you've done all the transposing and you have the I alone, then you should use your calculator. And remember, to work out I, we always have to times by 100 if you want to give the answer in percentage form. Let's do that calculation, and this is what we obtain. 13.62%. So the interest rate there is 13.62% per annum. Next, we want to look at calculating the period of investment. So let's take a compound growth again, and we want to work out the N value, the period of investment. The general approach here again, preferably always do the substitution first. Then we'll make the N the subject. And in this case here, to make N the subject here, we'll have to use logarithms to make N the subject. And you can either use this key on your calculator, or if you don't have that, it will be the logarithm divided by a logarithm there. Let's take an example. After substituting, again there, we have to transpose the 3,000. Transposing the 3,000 give me 5,000 over 3,000. Again, don't use your calculator yet. Now to get the N here, this is exponential, and the inverse of exponential would be logarithmic, right? So I'll have to get the logarithm, and this base there becomes the base of the logarithm, and there I have my 5,000. If we put this in your calculator, the answer is approximately 4,5. We could also have done it like that. So we can have logarithm. So you can say logarithm of 5,000 over 3,000 divided by the logarithm of the base there. If you don't have that key, you can always do that, and it should give you exactly the same answer there. Now we're going to look at the concept of an annuity. Let's look at the concept of an annuity. Let's say we put a lump sum of 5,000 Rand into a savings account. It yields interest at 12% per annum, and it's compounded monthly. And we let that money, in other words, we let that 5,000 grow over a period of time. Then we can find out how much money you will have at the end of that 10 years. So just that once-off lump sum growing at 12% for 10 years. But usually when people have to save for retirement, they don't put in a lump sum and let that lump sum grow, right? You don't have such a large lump sum. What usually happens is that you put in a regular amounts, let's say 2,000 Rand every month, and those regular payments, those many payments of 2,000 grow compoundly over a period of time, right? And this here, so it is regular payments, regularly. How regularly? Every month. And what's the amount? 2,000. And you let that grow there. Now this situation where you have regular payments, right? Regularly at either monthly or annually or quarterly, and it's a fixed amount, that is referred to as an annuity. That is a series of equal payments. See, the payments all have to be equal, and the periods have to be equal as well, equal periods. So it's every month. You can't have it once a month and then after 3 months again, and once a month. It must be every month. And this here is referred to as an annuity. Let's go over some definitions. Yeah, an annuity is a series of equal payments made at equal periods of time. Okay. Then the time between payments, is known as the payment period. And the time from the first payment to the last payment, that's known as the term of annuity. So let's say you have monthly payments, so that will be the payment period. But you're going to have it for 5 years, and 5 times 12 would be 60. That will be the term of the annuity. The term of the annuity would be 5 years, which actually means it's going to be 5 times 12. They're going to be 60 payments. Let's look at where we can use annuities in everyday life. First one, to accumulate funds. So we have regular deposits into a savings account. That's how you can accumulate fund. That is an annuity. Or we can have payouts. You know, if you have a pension fund, so every month you get a payment of a fixed amount depending on the agreement there. Then if you take a loan, you have to repay the loan, and those repayments have to be regular payments over a period of time there. So those are 3 types of examples of annuity. There are 2 types of annuities. The first type of annuity is known as an ordinary annuity. Now, what is an ordinary annuity? It's an annuity where you have regular equal payments, and here it's ordinary because the payments are made at the end, and also that the frequency has to be the same, right? So the payments need to be at the end and the frequency has to be the same. Then we have an annuity due. Here we have an annuity where the regular payments are not made at the end, they're made at the beginning of each period, right? So you can see the difference between ordinary, this one is end and this one is beginning. There are 2 values of annuities, right? And to look at this, we're going to consider 2 options of purchasing a car. The one option would be borrowing. Otherwise, you don't have the money, so you take out a loan and you want to purchase the car now. Right? Take out the loan now. So let's say there we have a scenario. You have you take out the loan, and that will be at T0, and then after you make your regular payments, there's at 5, and you can continue 6, 7. It depends on whether what your agreement is. So let's say up to 60 payments, or you can have 100 payments. So let's say we have 100,000, and we make our regular payments and another payment. So that 100,000 will keep on decreasing until eventually, after you made all your payments, your balance you should then owe 0. Right? Now this 100,000, when you purchase the car, you purchase it now. So that 100,000 here is the present value of this annuity. And this 0, the value, that's the future value of the loan would be. After all the payments, the future value would be 0. Let's look at the second option. Instead of borrowing to buy a car now, you could actually save to purchase that car in the future. You don't want to purchase it now, you want to purchase it in the future. So in other words, there we have, let's put our timeline down there. So we have so you start, when you save, you first start off with nothing. Then let's say the end of the first month you make a deposit, and then your second month and you keep on making deposits, and depends on what your objective is. Let's say for 60 you can make 60 deposits. So eventually this R0 and was all the deposits have grown, and let's say it grew to amount of 100,000. Now this 0 here, presently it is worth nothing, right? But after all the deposits, this 100,000 is the value in the future, right? So in this case here, we got starting with a high value and then you end up with 0. Here you start with 0 and you end up with a large amount there. We just summarize the two values that we just discussed, future and present. So future value is the value of the annuity at the end of the term of the annuity, right? Where the present value is the value of the annuity at the beginning of the term of the annuity, right? So there we have end and there we have beginning. So you have to know the difference between the two of them there. Let's first start with the future value of an annuity. Let's recall again, what did we say is a future value of an annuity? It's the value at the end of the term of the annuity. Now to do this, let's look at an example. Here we have 1,000 Rand, which is deposited at the end of each year, and is done for the next 5 years, and it's done annually. You see, each year and annually they match, and then we have end, and that's 15% interest compounded annually. Calculate the value of the investment at the end of 5 years. So let's put out our timeline there. So let's see, we start off. Initially we had nothing, so he deposits after the end of the first month, a year, he deposits 1,000, then the next year 1,000, and then the next year 1,000, and the next year until the, and we want to know what is the value of all his deposits at the end of 5 years. Now let's look at Nabil's investment in a little bit more detail. He's going to deposit amount, and it's going to be over 5 years. It's going to be 1,000 Rand regularly. It's going to have 1,000 Rand. Now that 1,000 Rand, that first 1,000 Rand will be in the account for how many years? For 4 years. So it grows, and that 1,000 Rand's value would be 1,000 at that interest rate, 15% for the 4 years. Then he makes his next deposit at the end of the second year, and that 1,000 Rand will be for how many years there? That's right, you can see it's for 3 years that amount will be in the account. So there's the value. We're not going to work out the exact value, just keep it in that form there. Then the third deposit, and that third deposit will be there for 2 years. So that's the value of the 1,000. That's the future value. See, this is in the future. And then the next one there, the 1,000, and that 1,000 there is for 1 year. And the value, the future value of that 1,000 would be that. And then he makes his last deposit at the end of the 5th year. So it's the end, so there's no interest there, so it just stays 1,000, and you know 1 plus 0.15 to the 0 is just 1,000. Now we want to now sum these values. To find the future value, it's a series. So we add each of these terms, and let's start from the bottom. So that's 1,000. I'm just leaving out the 0 part there. That's the second last and the third, and there we've added our 1, 2, 3, 5 terms there. Now if we look at this, we can simplify this. What do you notice there? Yes, that's right, we can take out 1,000 as a common factor. And if we take out 1,000 as a common factor, that is what we get, right? You don't work out the individual terms values, they just keep it in that form. Now what do you notice here? That's right, this is a series. What type of series? That's correct, a geometric series there. So we use the sum formula for a geometric series, and if we substitute, what is your A value? The A value here is 1, and the ratio is, there's the ratio, 1 plus 0.15 times another 0.1 plus 0.15 plus a 1 plus 0.15. So if we substitute that, so that's the A value is 1, the ratio is 1 plus 0.15, and the N value, there are 1, 2, 3, there are 5 terms, right? And this here will give us a formula for finding the future value of an annuity, right? Let's just try to generalize this. So we can just write it in color. There's the 1,000. I just put the 1,000 there. I put my interest in that blue color there, 0.15, that's also, and you see 1 subtract 1, they just cancel. I'm just left with 0.15. Now we can generalize here, and we can calculate it. So its value would be 6,742 Rand and 38 cents. Let's generalize that. So the future value, you can see there's the format. I'll have a bracket, and then I have 1,000. That 1,000 is let's put an X for the 1,000. And for the interest, let's use a I. There's another I here at the bottom. And there we have the formula for future value. Where this X here represents the regular deposits, the I is the interest rate, and the N is the number of payments being made there. And there we have a formula. We derived a formula for future value. You're not won't be required in the examination to prove this formula, but just for you to understand the concept of a future value of a annuity formula there. Let's put this all together. So this formula here, you don't have to memorize the formula. This formula is given on your information sheet, right? But you need to understand what these symbols stand for. F stands for future. X stands for the equal regular payments. I stands for the compound interest rate. And N stands for the number of equal payments. The number of equal payments there. And that is the formula we'll use for calculating a future value of a annuity. Now let's look at how we can derive a formula for future value of an annuity due. What's an annuity due? It's an annuity where the payments are made at the beginning of the term, not after 1 month or after 1 year. Let's take an example again. In this case, Nabil deposited 1,000 Rand, but he now deposits it at the beginning of each year, not at the end, but at the beginning. And it's also there for the next 5 years, and the interest rate is 15%, and it's also compounded annually. Let's look at our timeline. There we have a timeline. Now he's making the payments right at the beginning. Right? Beginning of the first year, beginning of the second, beginning of the third, beginning of the fourth, beginning of the 5th year. Okay, and we want to find what is the future value of all these deposits if he makes a deposit at the beginning. Now let's look at the situation in a little bit more detail. There we have our timeline. He makes a deposit of 1,000 Rand. Now that 1,000 Rand is there now going to be, because it's at the beginning, it's in the account there for 5, and that's the future value of that 1,000 Rand. Then the next one at the beginning of the second, that's going to be there for 4 years again, right? And that's the value, future value of that 1,000 Rand. Then the third deposit at the beginning, and then the fourth deposit, that's there for 2 years, and then the last deposit is there only for 1 year. And because we want to find the future value, this is a series, so we find the summation of that. So let's write all of them down. There's we start from the bottom. There's our 5 values there. Now, what do we notice here again? Again, there's a common factor, but the common factor isn't just 1,000, it's 1,000 times 1 plus 0.15. Take that out as a common factor, and there we get a series there. There we get a series. And what do you notice about that series? Again, it's also a geometric series, and we can use the sum formula for a geometric. There's the sum formula for the geometric. So the A value, this is the series here, the A value is 1, and the ratio again is 1 plus 0.15. If we substitute that, there we substitute in the sum formula. Now we can just simplify that. If we simplify all of that, we end up with this. So instead of putting this here, that 1,000, I put the 1,000 there, and this times, I just put it at the back there. So that 1,000 is this 1,000, 1 plus 1.15, I just put it at the end. And now we can generalize. If we do calculate it, you can see that the future value, we put it at the beginning, it's going to be a different value there. So let's see there again. The 1000 becomes my X value. My 0,15 is my I value. There's another 0,15, and then we have this 1 plus. So the only difference is you take the future value and you times it by 1 plus I. And that's the formula that we use for future value of an annuity. Let's just summarize the future value of an annuity due. So we see here, there's the formula. So it's the future value, and we just times it by 1 plus I. F stands for future value as well. X is my equal regular payments, and I is my compound interest rate, and N is my number of equal payments. Next, we're going to look at the present value of annuity and derive a formula for the present value of an ordinary annuity. Let's just recall again. The present value of an annuity is the current value of the equal future annuity payments at the beginning of the term of the annuity. So this is the value at the beginning of the term. Let's take an example. We've got Vio, and she would like to withdraw 100 Rand at the end of each month for the next 5 months from her account, paying 12% per annum interest compounded monthly. And we'd like to know what is the value of the amount she needs to invest now, right? So there's 100 Rand, and going to have it at the end. So that's an ordinary annuity, and it's every month, and it's going to be for 5 months, and it's 12%, and it's monthly. And we want to find what's the value of the investment now that she must make. So that's the now means present. Let's look at the timeline just to fully understand that. So we want to know what is the amount she must deposit now. That's the amount that is unknown there, right? The amount at the beginning. But she's going to make regular withdrawals, 100, then another 100, and another 100, and another 100, and another 100 at the end of each month. So we're interested in finding what is the amount she must deposit, and this is the amount, the present, this is the value, this is the present value that we want to determine. In the next slide, we're going to derive the formula. Let's look at Vio's situation in a little bit more detail. She's going to plans to make 5 withdrawals of 100. Now, this 100 Rand she wants to make that withdrawal at the end of the first month. And we'd like to know what is the value of that 100 Rand now. So if I want to work here to the present, I'll use the present, which is A divided by that, which is A times that. So this is just bring it 1 month forward. So that will be 100, and that will be to the -1. The second payment, if I bring it to the present, it will be that amount there. And the third payment, I bring it to the present, it will be that amount there. And the fourth one, I bring it to the present, it will be that amount. And the last withdrawal, if I find the present value of that last withdrawal, is going to be this amount there. Because we want to find the sum of all these present values, we can add them. So there's the first, the second, the third, fourth, and the fifth. And like we've done before, we can take out a common factor. And here you notice the common factor is 101 plus 0,01 to the -1. Take that out, and those are all the terms that we have there. Again, we see that this is a geometric series. You can apply the sum formula of a geometric series. There we have the sum formula. Now the only thing we need to do now is to simplify. You can see if I remove the brackets there, that -1 subtract 1, that will cancel. I'll only be left to and so I can't subtract that there. Be careful. So let's just multiply that out. So there's 100. I multiply this with that one we don't need, this with that gives me that, this with that gives me that, and then I have this here at the bottom. Okay, So that can be written as, if I simplify this, this is the value that I get here. Then and if I simplify this further, there's the 100. I eventually end up with this here. Now we can generalize. That 100 becomes my X value. That 0,01 becomes my I value. And I have another 0,01, and that 5 becomes my N. Okay. Now, grade 12, you don't have to know the proof of this to be able to set it, just to show you the concept of present value. It's that one there, you bring it to the present. The second payment withdrawal, you bring it to the present. So this is the sum of all these present values, and this is the formula that we get for that. Now let us just summarize the present value formula. So there's the present value formula. Notice there the difference between the future value. There's the X is the same X, same I, and the N. Just be careful here that there we have a negative N. Present, that's the one with the negative. This formula you don't have to memorize, it's given on the. Now that we've derived the formula, we're now ready to do some applications of future and present values of annuities. But some direct applications. I was just directly applying those two formula. Let's look at the first example. Remember, I always advise you to read your questions carefully. So let's look at this. There's the example given. So let's just read it now. First of all, we want to determine when reading it whether this is an annuity. Can you see why? What do we have to look for with its annuity? Yes, it's an ordinary annuity. And why is it an ordinary annuity? Because the payment, the deposits are made at the end, right? It's at the end there. And it's an annuity because it's every month you're making a payment. It's not a lump sum deposit. And there we see every month, and the compound period is also monthly. Now, is this a present or is it a future value? What tells us it's a present or whether it's a future? That's correct. It's a saving. You save for the, what do you save for? You save for the future. So this is a future value. In other words, we'll need the future value. We need to identify the values or the amounts that are given here. And what are the amounts? We have 500 Rand, which is our, which value? That's our X value. So the X value is 500. Then we have the 10%, and the 10% is my interest rate. And remember, it is monthly. So it's 10% divided by 12. I suggest you leave it in percentage notation there. It's much easier. Then 5 years, that's your N. But remember, it's N years and it's monthly, so it's N times 12 is equal to 60. We'll go to the next slide to. Now let's look at this question, the solution of this question there. There we've got the question with all the information there. So we're going to use the future value. Remember, we said it's savings, therefore we will use the future value there. So it's 500 Rand, that's the X value. We've got the I, 10% over 12, N is 5 times. I would just have to substitute these values in the formula, and substituting them, this is what we obtain here. X is 500, I is there. Don't do any little bits of calculation, just keep it as 10% over 12. Now we have to go to the calculator and just be careful. And your calculator skills have to be good. And if we calculate that, we get 38,718 Rand and 54 cents. I advise you with this calculation, always do it twice, just to write it down first, recalculate it, and then compare the two answers there. So after 5 years, the future value of his investment would be 38,718 Rand and 54 cents. Now let's look at our second example. Let's take the second example, and there. Remember, we always have to read it carefully. Now, is this an annuity? Why is it an annuity? It's an annuity due. Why is it an annuity due? See, the deposits are made at the beginning, so it's important that you read carefully. Beginning tells me it's an annuity due. then, and we want to find the value at the end of the period. That's going to tell us something, and it's every quarter we have to match, and we see it's quarterly, so every quarter match with quarterly. Is it a present or a future value? He's making a deposit at the beginning. You want to find the value at the end. The value at the end is a future. And what also tells you it's a future, you can see there it's a savings account. You save for the future. Now let's just identify the given values. There's 5,000. And what is that 5,000? That's my X value. There's 10%. That is my interest rate. And it's quarterly. So be careful you don't highlight that. It's 10% over 4. And maybe you can rather leave it as 10% over 4. You don't have to simplify that. And then 5 years. And it's going to be quarterly. How many quarters in a year? That's 4. 5 times 4 is 20. Right. In the next slide, we'll actually do the calculation. What's important is that you read, and this was the key, beginning, right? So you must read carefully, and it'll be advisable for you to highlight there. So beginning, that means it's an annuity due. It's not, the payments are not made at the end. So you have to be careful. We'll have to adjust our future value formula that's on the information sheet. Now let's actually do the calculation. I'll just put down the question there again. So we said it's going to be future value, but because it's an annuity due, it's beginning, we have to adjust the formula. We have to add that portion there. Now it's just a matter of substituting. The X is 5,000, the I is 10% over 4, the annuity period is 5 times 4, which is 20. And if we do that substitution, and then the only thing that's left here is to do our calculation there. So just be careful how you enter this on your calculator. And if we calculate that, this is the value that we get, 130,916 Rand and 37. And I advise you, once you do this calculation, write down the answer, do it a second time and see whether you get the same answer. Then you can see whether you, because you could easily make a mistake by not entering the values correctly there. Right? You could also, with this one, you type in, you don't have to use that special key on the calculator. You can just type in that. Then instead of that, you press divided by this and then times by that. But the use of the brackets here is going to be important. If you do not use the brackets correctly, you will not get the correct answer. So that 5,000 Rand over 5 years and quarterly deposits is going to yield that amount there. Let's look at another example now. Here we have Natalie as a bank loan, so we have to read the question. Is this an annuity? And what type of annuity is it if it is an annuity, right? You see there's repayments. That gives us a clue it's an annuity. And it's made at the end, right? In this case, that tells you it's an annuity. It's an ordinary annuity. And it's every 3 months, and we notice quarterly means the same as every 3 months. So that matches, so that definitely is a ordinary annuity. Is it future or is it a present value? There should be some clue there. Yes, it is a present value because a loan, you take the loan out now, right? So that's a present value. Again, they emphasize loan. So it's definitely, so we'll have to use our present value. What are the values in this here? It's the 5,000. And what value is that? That's the X value. And the 15%, that is the interest rate. But quarterly, be careful. So it's 15% divided by 4. N, that's 10. But that, because it's quarterly, it's 10 times 4, which is 40. Now let's actually look at Natalie's investment here. So we said it's a present value. Those are the values. So we just have to enter those values there, substitute. And if we substitute that, this one is quite easy. Be careful with that negative there. And if we calculate that, the present value is 102,000. So the loan amount that you had to take was 102,754 Rand and 94 cents there. Right? Again, as I said, do the calculation twice. Make sure that you have entered the values correctly. You could also type in that instead of that special key on the calculator, you can say divided by 15% over 4. And now we come to the most important part, is the exercise worksheet. But my advice to you is, before you actually start with these exercises here, just go through these slides again, but don't just listen to it. Try to, you can pause, let's look at, and then you try to do the question on your own, and then you see whether your answer matches the answers that are there, right? Don't just listen to it and observe it there. Try to do it on your own as well. But the important is that you need to understand the concepts. Now let's just briefly look at these exercises. So the first one, there you can see the first one there is a question that has to do with what we did, annual and effective interest rate, right? There we have the conversion there. Here we have questions about depreciation, calculate the annual rate, and here we want the period. So just some examples of calculating the I value and the. Here we'll have some questions on annuities, and you must read there. There it says at the end of every month. So that should tell you every month you actually invest there, right? And you see that's monthly and month. So this is an annuity. You'll just have to determine whether this is a future value or a present value. I don't want to tell you that. You tried that on your own. So it's important that you read your question. Here's another one. Can afford monthly payments. At that, the bank offers a loan. So what does a loan imply to you? And that's compounded monthly, and she's making monthly payments. Then the last one here we have invest, and you invested at the beginning, not at the end, the beginning. This is an annuity due. So those are the examples there that I would really recommend that you try to do them. Now class, this is part 1 of the finance. There's also part 2 and part 3. You can also look at that. And there are other videos that I prepared on grade 12 CAPS mathematics, such as calculus and analytical geometry and inverse functions. And you can find that on my YouTube channel, Maths with Armin. I would really appreciate if you can subscribe to my YouTube channel. Thank you very much.